All right, I'm going to record a video that goes through how we'd solve a problem like number 4 in the angled launch problems worksheet. So this is one where you might use the quadratic formula, which is pretty exciting. We're going to say, I don't remember the exact numbers from that problem, but we'll say that the initial speed is 10 meters per second. Our angle above the horizontal is 60 degrees. Let's say that the launcher starts from a height of 1 meter. Let's say that the basketball hoop is at a height of 3 meters. And then let's try to figure out how far away do we have to place this launcher. Okay, so as with all angled or horizontal launch problems where we got motion in 2 dimensions, the thing that'll tie both of those dimensions together is time. So I first have to find time, and then I'm going to have to look for whatever variable I'm looking for. Okay, so I'm looking for the distance away that this thing has to be placed. So I'm looking for delta x. Okay, I'm going to find the time it's going to take to get to this hoop. And then once I know that amount of time, and I know my speed in the horizontal direction, I can find delta x. All right, first things first, I'm going to break down these into components. So VIY is equal to, that would be 10 meters per second times the sine of 60. So let's say 10 sine 60. So that'd be 8.7. VIY equals 8.7. Vx is equal to 10 cosine 60. I remember that for unit circles, so that'd be Vx is equal to 5 meters per second. So I'll put that down here. So the initial y speed is 8.7. The speed in the x direction, again, this doesn't change, so I'm not going to put Vix. I could put Vix. It's the same thing as Vix, but this would be 5 meters per second. And I should be able to solve this. Okay. So I know my initial y position, final y position, initial y speed, and I know that it's accelerating in the y direction at negative 10 meters per second squared. So anything that's a projectile or anything in the air always will be accelerating downwards at 10 meters per second squared. Okay, so in order to solve this, I'm first going to solve for time. I'll use my first kinematics equation from this. So that would be y is equal to y initial plus v initial in the y direction times t plus my acceleration in the y direction times t squared, 1/2 of that. Okay, so I'm going to plug in my numbers. I'll say 3 is equal to 1 plus 8.7 times t plus 1/2 times negative 10 times t squared. Okay, so I know everything here except for t. Just as a point of reference here, oh, no, never mind. Yeah, we will have to use the quadratic formula here every time. So anytime you've got both initial position, initial velocity, and an acceleration, when you've got all 3 of those, none of them are 0, you'll have to use quadratic formula. On the AP test itself, don't worry too much about that. Like if you've got a problem like that, it's probably going to take so much time that it won't be a multiple choice question, so it'll only be a free response question. And if you forget how to do the quadratic formula there, you'll probably miss like a point or 2. We'll go over that at the end of the year when we do longer problems, but this is just for refresher on quadratic formula. All right, anyway, I'm going to get all my terms onto one side, so I'll get 0 is equal to, I'll subtract 3 from both sides, so I get negative 2 plus 8.7t plus negative 5t squared. Okay, for quadratic formula, I need to know this coefficient, this coefficient, and this coefficient. So the general form of it is 0 is equal to ax squared plus bx plus c. All right, so in terms of my variables, I'll write down which is which. So I'd say a, that's my coefficient that's for the squared term, is negative 5. I'd say b is equal to 8.7, and c is equal to 2. All right, then my quadratic formula is that my solution is going to be negative b, so negative 8.7, plus or minus square root of b squared, so 8.7 squared, minus 4 times a, which is negative 5, times c, which is 2. All over 2 times a, all over 2 times negative 5. Okay, so my time is going to equal negative 8.7 plus or minus the square root of, let me do that in my calculator, 4 times 5 times 2 would be 40. So 8.7 squared minus 40 would be 35.7 over negative 10. So that'd be t is equal to 8.7 plus, let me take the square root of that. 35.7 square root. Okay, so it'd be negative 8.7 plus or minus 5.97, so let's just call it 6. 8.7 plus or minus 6 over negative 10. So t could be, if I add 6, I'm going to get negative 2.7 over negative 10, or it could also be, if I subtract 6, negative 14.7 over negative 10. So t is equal to two different numbers. So it'll either be 2.27 seconds or 1.47 seconds. Okay, we got to think about, in the physical context, what does t represent? T represents the time at which our final position is 3 if our initial position, initial velocity, and acceleration are these numbers. Okay, so we're looking for the times where our final position is 3. Turns out there's going to be 2 times where that happens, right? So if we shoot a basketball into the air, it's going to follow that trajectory. This line represents where y is equal to 3, so that's when our final position is 3. That happens early on in the trajectory, so that'd be this first time right here. It also happens later on in our trajectory, so that'd be our second time. So given our physical situation, and given that it passes that point 2 times, it makes more sense that this is the one where our basket would be, so we're going to use this as our time. Okay, so I'm going to say t is equal to this, and then the rest of my problem I'll just do. It's pretty straightforward. So that was the quadratic part, but we can say Vx is equal to delta x over t. So Vx would be 5. That's equal to delta x, which is what we're looking for, over 1.47. Okay, to solve this, I'll multiply both sides by 1.47. So times 1.47 times 1.47 times 5 equals 7.35. Okay, so delta x is equal to 7.35 meters. Okay, so that'd be about 20 feet away from the basket, and that's our answer.